Hello, welcome to my talk about desired state for complex applications. So let's get started. What we'll look at is, at the first, our vision, what we are trying to achieve with the thinking that we are doing right now. First, a server deployment, a VM deployment is mostly a solved problem. As I talked last year, the tools are there, they are ready, they are usable, that's fine. And also simple applications like an Apache and Tomcat, a database, is more or less solved. I'm working with SAP systems, so we will look at how a SAP system looks like, a simple one, a more complex one, and look at how we can describe such a system so we can, in the end, deploy complete systems or more complex systems. And looking at the future, there is a concept like an SAP landscape where there is a development, a test, and a production system that work together. They are similar, and we are thinking about how we can describe such a configuration. And if we look beyond that, more system landscapes interacting with each other are the next step that we see in the far future. So the vision we created about 5 years ago was we wanted to describe a complete system with minimal input. That's the key part. Everything that can be derived from defaults, that is clear in our environment, or from the context we are in, that shouldn't be asked for the colleague that orders a system. And we want to generate a blueprint, we call it also bill of material, how the system in detail looks, what file systems, what users, what network addresses, and so on we have. And this is only really useful to do if we can deploy and manage the systems with automation in the end. So if we have a clear picture how the system should like, and we have a deployment that automates our management and the installation, then we can do a lot more work and much better. So what we have is VM server deployment that works fine for us. Some people call it infrastructure as a service. Mostly in the industry right now, I think we are using Terraform and openTofu. Something we internally don't use right now, but I think we will do it in the next couple of years. And also use Cloud Init to get started with our automation. What's the real point is, we don't run a server just for fun. We want to use an application, and the application needs things from the operating systems. And so what are these things that an application needs? And everybody from us has been working with some things. For example, a database has a name. So if I can say, oh, I need a database called ABC, the deployment can just manage and create a database. And if I have a template with the data structures, that's fine. So Ansible or something else can also deploy a database. And many other things are derived, for example, from a database name. For example, a TSL certificate, a monitoring script that needs to be created, a backup configuration, whatever. So just deploying an application makes it possible to do a lot of more things to integrate into the structure of the data center. And now we are drifting to SAP and look at an example like we create a HANA database, and more or less the only input we need is what's the name of the database and what the database instance and the tenants, the databases that the application uses at the end. And these two informations give us the possibility to create the needed operating system users, to create file systems that we need, create logical host IP addresses, DNS names, TLS server certificate names, and so on. And that's something we do since about 4 or 5 years. And we were able to create, for example, a year ago, about 100 databases just in a couple of days. And how looks a server with such a database? We have a server with an operating system image. We create IP addresses, logical hosts in SAP speak, that can move, for example, with cluster software to another host. And we have file systems, HANA data, HANA log, and some more. But that's to get the picture. What we are looking right now at is to get more resilient, to get better availability. So we are thinking about more clustered databases. And there we see some benefits from using configuration management to describe the landscape. The additional input, and that's the only one we need, is this should be a clustered database. From that output we can derive, we don't need one server, we need 2. Easy. We can just create a second host name. They are already crazy looking, so just add 1 to the number, for example. We need a second network interface to do the system replication. That's nothing that the person creating the database needs to know. We just do it in the background. For clustering, we need the standard block devices, we need the cluster software and the cluster configuration. Nothing we need to ask for. Already we know that we need that and how it should look like. And we have some changes at the DNS network configuration, but that's also something we shouldn't ask for. The takeaway is, and that seems to be the case for lots of application classes, to move to a clustered system, you don't need to specify a lot from an external perspective. But in the background, you need to do lots of things. Let's look at the example I presented earlier. We need a second server, so just create one. It's a copy, it's a mirror from the first. It looks exactly the same. The database has the same name, the same size, the same. That's fine. We do need a second network. We can generate that. We need a pacemaker. We said we need a cluster, so it's clear. We need a pacemaker on both systems. They need to talk to each other. The HANA database should use system replication internally. We have every information there to create that. And the service IP to get the access to the database is also more or less clear. So that should give a view into the future how a system might be ordered from an outside perspective, even if in the background there are lots and lots of details to take care of. So we have some tooling for that. The first thing is you need to think about the data structures. What does your input look like? Do you need a list, just a name, something like that? Lots of parameters we can validate. For example, we know the different types of network we have and where we can work. Each service that we call, for example, a HANA database or an SAP system or something else, is kind of a building block that we use so we can build up more complex systems. And each of these building blocks has its own standards, its own default values, its own conventions. But most of the time you can just use the default. Most of the questions we can answer with, oh, it doesn't matter for me, just take what's working. We have a Python script that takes the input, the minimal input, with some external data sources, for example, DNS or IP management tools or something like that, and creates a complete bill of material that we can use to create a VM with Terraform, to use as a pillar in Salt or as Ansible variables to just configure the systems in the end. And as long as we don't have everything automated, we can also create a request for comment or a change with a special standard text. So each time we need something getting done manually, we always have a similar order, so never discuss with, oh, there is about a comma missing or something like that. And also for our internal use, we can document the manual steps we need to do, so long as we don't have automation for that. Right now it's Python scripts. We are looking at things like getting a web overview for something like that, but that's in the future for us. And the backend needs a lot of automation with Ansible, with Salt or scripts, whatever works for us we are using, as long as it can read the data source we have, and the minimal input also for us is assigned to not enter the same data twice. If we need to enter an IP address here, IP address there, IP address in another tool, we are bust. People get it wrong some of the time. So if we look at an SAP system, that's the application our customers use. What's the input we need to do? What describes an SAP system? The first is the SAP system ID, short SID. The part of which development landscape the system will be. This describes the software release, the components that need to be installed in the system. Also, we have some systems with special network restrictions, so they need to go in a restricted network. That's something we can derive from. This is part, for example, of the SAP Solution Manager landscape. The usage we ask for, this helps us to get better monitoring, get disk mirroring enabled, and the backup schedule for production systems is another one than for a non-productive system in our environment. And the last really important data we ask for is, where do you get the data from the system? Is this a completely new system? You get a DVD from SAP, downloaded of course, or is it a system copy? Just take this system and make a new one from that. And as well as for a HANA database, we get an output, we create logical hosts, we create IP addresses, DNS names, whatever. We have users with storage file systems, and so on. And most of the things that we need are the same for each system. And that makes it really, really easy to create and maintain a bigger landscape. Just a picture from an SAP system running on a server with a database. The database and the SAP system each have a logical host, so we can move them to another host and keep the IP addresses and the names for the application the same. So far for a normal SAP system. And we looked at our landscape and tried to decide what kind of systems do we provide. Where are the benefits using templating and automation as we do it. And we found more or less 3 types of systems that we have in a bigger number. The first is all-in-one database and SAP system on one server. Pretty easy to manage, easy to deploy. That's butter and bread, we call it. We have systems that the database and the SAP system are on different hosts. This is mostly technical. The HANA database runs on Linux, and the SAP system for some services needs to run on AIX, so we have a distinction there. And the third one, and that's a point, what we think we will get more in the future is a fully clustered SAP system. So instead of one server for an all-in-one, we get 2 servers for the HANA database, 2 servers for the SAP Central Services cluster, and 2 to n application servers to get fault tolerance. And everything else we sometimes have to do is a lot of manual work, has a lot of potential for errors, and generates snowflakes that in the future, in the maintenance, are horrible to handle. So my hope is that we can more or less all our systems get from these templates. And if we look at a clustered SAP system compared to a single instance system, what do we need as information? Just the number of application servers, the number of CPUs, and the amount of RAM we need. And from that, we can generate an output. We need 2 virtual machines for the HANA system replication or another database. We need 2 VMs for the SAP Central Services clustered, and NVMs as application servers. We have lots of logical hosts, lots of IP addresses, DNS names. The certificate SAN list gets pretty big. We have predefined storage file systems, so they are very, very similar to the application server that we deploy. And also OS users, we need to have the UID of these users the same on all clustered systems. That's done with automation. Nobody can do any errors here, so that's really, really helpful to do so. That's a picture of such a system, and the bottom line is the HANA system replication cluster. That's a couple of slides ago, the picture where we had the 2 databases created with the pacemaker cluster. This is just a building block that we can reuse here and just call it in the blueprint to say, okay, we have an SAP system that needs a database. What kind of database? And so we get Stücklistenauflösung, we say in Germany, just a bill of material gets created, exploded from the data that we provide. So for now, we did, for example, the cluster systems with the manual creation of the building blocks. We looked at each server. We need a server for a HANA database, or we need a server for the secondary HANA database. We need a server for the RCS, for the NQ replication server, and we need a couple of application servers. That did work out. Didn't take too much time, but thinking about it, it doesn't work with our vision. Our vision was get the minimal input. And we said on a dozen servers, we need that subsystem ID. That's something we don't want in the future. So in the future, we just want to say, build me a complex SAP system, and the building blocks, the servers, the database, the cluster, etc., we will just generate in the background. Why is that useful, and why we are thinking about that? We will get more and more systems of that complexity. the past years, we just doubled the number, and my guess is that the next 2 or 3 years we will double or triple them again. We will get clusters on every scale, I think. What we've learned the hard way, just as anybody else, manual building a system and a configuration is hard work, is error prone, and debugging in such an environment is just horrible. Once we have automation in place, and lots of automation we have, systems get far easier to build. In the distant past, 5 years ago, creation of a logical server, of a virtual server, was horrible. It just was confusing. And right now we just build a new one. It takes time, yes. We are not fully automated yet, but the quality we get with our bill of material and the automation is far better, so we have lots less manual work. That's what we do now. What we are thinking about, if we look at the future, we do see something that will come next. And then that's it. I call it at the horizon. That might be part of a talk in a couple of years. You don't have an SAP system in production running just as one system. You need a development system where the customer does customizing, does software development, and the created artifacts get transported into the quality assurance system or test system and the production system. So you have a landscape that more or less has the same software release and is, besides the subsystem IDs, relatively similar. And how might such a system look like? What are the key facts that describe such a SAP system landscape? From the SAP internal view, it's a shared user subtrans file system, mostly via NFS in the past, that transports the development from the development to the quality assurance and the production system. And if you look at what SAP in the public cloud does, there has each system its own user subtrans, and with SAP tools they move the data from A to B, so no NFS, and that's something we look at our architecture if we can lose the NFS too, because it's not easy to manage. In the landscape, we have a transport domain controller that has a configuration, also a backup domain controller, so you can still change the configuration if one system is down. And as I said, this SAP software releases are more or less the same. If we have an upgrade, we start with the development system, and a couple of weeks later, the new release rolls through the landscape, but that's a thing that is temporary. So for our purposes here, deploy a new system, we just know what the default release is that we want to deploy. What the systems also have is, let's say, communicate internally via remote function calls. This is an SAP protocol to call ABAP code from another system, and there the development, the QRS, and the production system talk with each other. So we need firewalls, we need maybe security gateways, whatever, in that story, and that's something we just know. There's nothing we should ask a customer if he comes and says, oh, I need a new landscape, that he just defines it in detail. And what we also see is if the development system talks with, for example, the business warehouse system, the QRS systems most probably would do the same as well as the production. And we can derive the VLANs we are in because some systems, some landscapes have their security and restrictions so that they are in special VLANs, for example. That's something we hope to have in a year or two. We will see how that works out. And if we look beyond that, just as I said, our ERP system talks with the business warehouse system. We have a solution manager. We have lots of landscapes that talk to each other. How do we handle that? Once we can describe an SAP landscape, what is missing to describe the complex picture of all the SAP systems we are running? We see that some systems talk to each other most of the time. We have other systems that are not talking bidirectionally. There are just jobs in the night where communication happens, or some systems don't talk with each other. We have lots of different SAP releases that we need to handle. But what's a thing we think about is for disaster recovery purposes and also for system copies is some systems are so connected that you need to take a backup or restore to a special point in time to get a landscape that is working at the end. For example, ERP system and BW system, if they don't match, the next data load will just fail. So that's something we look at, how we might describe that, and also what communication patterns and firewall rules we have. In our environment, we are talking about five figures firewall flows. So that's a massive load that we can't handle, and we need to find a solution how to describe the communication better. Also, when talking with security, to get a new firewall flow established. So, what's the conclusion? We've seen that the building blocks are useful to build more complex systems. What we have seen is that the building block server, as we have defined it in the last few years for us, don't work as well as we would like. We need to look at the building block from the application side, from the database, from the SAP system to be better. The vision to describe a system with minimal input makes lots of things easier and more manageable. You don't need to ask 20 times for the IP address or the host name or something like that. And that makes lots of things easy, but you need to think hard. Is this a thing that needs to be specified when ordering a system, or is it something we can derive from other data? And then that's the hard part, to really get a focus on what is really needed. And to work with minimal input, we need defaults. We need conventions that specify systems. As long as you don't say otherwise, it will be exactly that way. And then we can derive data. We have the prerequisites to enable all that is needed to get simple and minimal input. And in the end, completely automated, deployed, and configuration management. The automatic deployment we do delivers speed and quality, and from my point of view, the quality aspect is the key part here. Less errors, the systems look more similar, and we have lots of opportunities to do automation when running the system. If each system looks something different, it gets much harder to automate upgrades, configuration changes, something like that. But that's also true. Each of these automation of configuration management we do needs ongoing maintenance. That's a lot of hard work, lots of thinking, and lots of talking with people. What's really needed? What are the specifics that we need to consider? What we see is a complete description from our SAP landscape might be possible. I think it is. But we will have years of work to do to get there. But we want to get there. As we talk, we move only systems once, and that's always. So we are always creating new systems. We are always moving to other platforms and so on. So we need help to manage our systems, and that's the work we need to do. So that's the end of my presentation. Do you have any questions? We'll wait for the mic.
So you mentioned that you're using currently Python scripts to basically
Yes.
process the user input to further transform it for the input for the automation systems, I guess.
Yes.
Right. So that's kind of like a custom solutions, and once you get more and more complex, do you see, well, do you have to grow that custom solutions, or do you see some other maybe industry standard tool that maybe can take over that step between user input and then building more complex systems, right?
We are looking at other tools, so I haven't seen one that looks somewhat promising. So I think we will still need custom code, but now we have a Python as a command line. We specify the system in YAML files and get a bigger YAML file out from there and use this as a pillar or ansible vars file. So that works pretty well, but is not really user-friendly, and we got already years ago the wish to be better there. So what we are now looking at is something like Streamlit to get from a data description a web interface that you can just fill in the blanks and get YAML files from out there, and they look not as our input as we have it now. So we will need to change our automation in the back end, but that's something maybe that we will use in the future. That we are just doing proof of concept right now. To get a feeling, how does it work? How will it feel? And the presentation here was kind of get my brain around the things to talk about, to just get a feeling what we need to do.
Thank you.
Another one? Okay, thank you.